Come again. So we are today here with properties of whole numbers, and we will study here commutativity, okay, of whole numbers. In respect of the operation, four operations are there. First is the addition, second is subtraction, and third is multiplication, and fourth is division. Okay, so for four kind of operation we will see whole numbers are commutative or not. Okay, so first all we need to understand what is commutativity. Okay, in the previous video we have studied about closure property. For the closure property, what is closure property? If we adding or subtracting whatever operation we are doing on the whole numbers, the same whole number should come on the as a result also. For a in the commutative, we need to see that if the whole numbers are interchanged, means the place are interchanged. Place means before operation and after operation, means after you will understand when we will tell you that how means this will affect. So we'll start with the addition. For addition, number one, for example, there are two numbers a plus b and the result is c. Okay, so this a is a whole number and b is a whole number, and we are getting result c as a whole number. But if we interchange these two, means interchange means in its position is interchanged, means b plus a. So then what comes? Does it comes c or some other number? Okay, if it comes c, then it will be said as it is a commutative. Commutative means if places are changed, the things will remain same. This is the simple explanation. Okay, so now we will see for addition. For addition, whole numbers are commutative or not. Okay, we'll see some examples, and we will also try to explain you through the number line. Okay, so see here, suppose 4 is there and 4 plus 5 is there, you will get 9. Both are whole numbers. Okay, and here you are getting whole numbers. If you change this position of both whole numbers, means 5 plus 4, you will get 9. Okay, so always you will get the same number and whole number itself when you change the places. Okay, now we'll see the in the number line also, as it is explained in a number line in the book also. Okay, so for example, we have here, this is 0 1 2 3 4 5 6 and 7. Okay, and we draw another line also. Let's write another line also. 0 1 2 3 4 5 6 and 7. Okay, so for example we are adding 3 plus 2. Okay, 3 plus 2. Okay, so for adding 3 plus 2, we need to start with 3. Okay, and then we'll make two loops on the right side because we are adding, so it will be like this. Okay, so where we reached at 5. Another way of making this as this also, we can directly also make like this. Okay, and if we change the position of 3 plus 2, means 2 plus 3. Okay, so we start with the 2 and we can 1 loop, 2 loop and 3 loop. So where we are at 5 itself, here where we are at 5 itself. So from number line also it is explanatory and self-explanatory that if we interchange these two numbers, then the result is same. Okay, so for means if you are changing the order, then the result is coming same. So what we will say, that addition is commutative for whole numbers. Okay, this is the final. I think you got the point. Okay, addition is commutative for whole numbers. Okay, got the point. So for addition it is a commutative. Okay, now we will go to subtraction. Okay, second point, we will go to subtraction. Sorry, it is to subtraction. Okay, so for subtraction, what we are saying at it is commutative or not. If B multiplying A to B, A, B are whole numbers and we are getting C, and if we interchange, this position of these numbers, means B minus A. So the result that comes here, will it be C or something else? If it is C, then it is commutative for subtraction, and if it is not, then it is not commutative for subtraction. So let's take some example. Any example you take, except means 0, and 0 also, for 0 also you will not get it. So let's take any example. 5 minus 2, you will get 3. If you change these places, 2, if you change the order of these numbers, 2 minus 5, so what you will get? Minus 3. Okay, and minus 3 and 3 are not same. Okay, if you take any number, any number, you take 15 minus 12. Okay, no, not 12, you take little certain number, smaller number, you take 4, what will get? 9. And if you change these places, interchange these places, 4 minus 15, so what will get? Minus 9. Okay, and this minus 9 is not a whole number also. Okay, and 9 and minus 9 are different also. So for subtraction, what we will say? For subtraction is not commutative for whole numbers. Okay, now we have come to third one. What is third one? Third one is multiplication. So what we will prove here? If we are multiplying two whole numbers, okay, and whatever result we are getting, if we interchange the places of the numbers that we are multiplying, whether we are getting same answer as a whole number or not. If we are getting same, then it is commutative. Okay, so let's explain it. Suppose we are multiplying A as a whole number to B, and we are getting C. Okay, if we change the order, means B multiplied by A, so what we will get? Will it be C or something else? If it is C, then it is commutative for multiplication. Okay, let's see. Any number you can take it. For example, 7 is multiplied by 8, so what will get? 56. Okay, so okay, so now you interchange these. 8 multiplied by 7, you will get same number, 56. Any number you take, suppose we are taking 12 and 2, so it is 24. If you interchange these, 2 multiplied by 12, you get 24. Let's take 0 also. 0 multiplied by any number, 6, it is 0, and 6 multiplied by 0, it is also 0. So you are getting same thing here. So for multiplication, it is true. Okay, so for multiplication, what you can say? Multiplication is what? Commutative. For what? for whole numbers, for whole numbers. Okay, it may not be true for real numbers or for other numbers, but it is true for whole numbers. Okay? So we need to write here for which it is commutative. Okay, so till now what we have studied, we have studied that for addition and multiplication whole numbers are commutative, and for subtraction it is not commutative. Okay, so now fourth is subtraction, division. Fourth is division. So it is very much obvious that it will not be also commutative, but anyway we need to explain it. Suppose A is a whole number and it is divided by another whole number, that is B, and we are getting C. So if we interchange these, B divided by A, so whatever result we are getting, will it be C or something else? If it is C, then it is commutative. If it is not C, then it's not commutative. Let's take an example. Okay, let's take 8 divided by 2. So 8 divided by 2, what will be? It will get 4. But if you interchange both, 2 divided by 8, so what will get? You will get 1 by 4. Okay, and these are not same. Okay, you can write this another way also, 8 divided by 2, like this you can write also, and 2 divided by 8 equal to 1 by 4. Okay, this is the another way of writing. Okay, by putting a symbol between the two numbers. So you will take any number except 1. Okay, except 1 means both are 1. When both are 1 or both are same, then it can be true, otherwise it cannot be true. Means if both numbers are same, 4 multiplied by 4, it is 16, and if you interchange it 4, it is also 16. But it should be true for all. Okay, then only we will consider. Let's take another example. Let's take 18 divided by 3. What will get? 6. Okay, and if you interchange both, 3 divided by 18. So what it be? 1 by 6. And these two are not same. Okay, and this is not a whole number also. Okay, so for division, it is not commutative. Okay, so what will write? Division is not, okay, not commutative for whole number. Commutative for whole number. Okay, so finally what we have studied, finally we can say, addition and multiplication are commutative for whole number. Okay, this is final our conclusion. Okay, sorry for bad handwriting. Actually with the pen and this tab, it is combination is not fitting. That is what we are getting, the handwriting is little bad, but I think you must be getting my point, what I want to tell you. So till now we have studied commutative property and the closure property. In the closure property we have studied in the previous video, and in this video we have studied about the commutative property of whole numbers. In next video we'll try to explain you about associativity of the whole numbers. What is associativity? Associativity means if 3 numbers are there and we are putting into some operation, and we take those numbers, 2 numbers together, and we try to solve it, and later on if we change it, then what will be the answer. And in next video we'll explain it how will so you just look at the next video and you will get the complete idea about it. So this is all. We'll meet again in the next video. Thank you very much.